All right, so A Day, you are a little bit ahead of B Day at the moment. Um, and of course, B Day, whenever you receive this lecture, you should be up to date. But for right now, A Day, we're going to focus on learning about solubility curves. Before Christmas break, we started learning about our solubility. What does that mean? We learned about our three different types of mixtures, which are supersaturated, saturated, and unsaturated solutions. And that brings us to our graphs here, which are known as solubility curves. So defining solubility by itself is going to be the ability of a substance to be dissolved, which is super straightforward, right? So if we look at this chart here, let's look at NaNO3. If it is on the line, it will be considered saturated. If the point you are looking for is above the line, it will be super saturated. And if it falls below the line, it will be unsaturated. So if we look, question 2, for most substances, solubility increases as temperature increases. What substances are the exceptions on the graph below? So that means look at the graph here. Most of our lines, as the temperature increases, the solubility will actually increase. So right off the bat, do we see any? Okay, I'm going to highlight 2. Ce2SO43. See, that curve is kind of going a little bit differently. Is there another one where the curve goes down differently? And H3 is another one. Kind of goes down instead of going up. So that would be our answer for number 2 here. Okay. If you haven't figured it out, majority of the worksheet is honestly kind of just looking at the chart and decoding information. So when we are looking at our graph, notice that one of our axes is talking about grams of solute. Solute, we know, is like salt or sugar. It's what's being dissolved. But it's talking about per 100 grams of water. So while the temperature is increasing, it's talking about grams per 100 milliliters. So if we're looking at question 3, what mass of solute will dissolve in 100 milliliters? So this right here for this question is actually matching. So first is KNO3 at 70 degrees. So let's find KNO3, which I will use a pink highlighter for this. KNO3 lands right here. And it's talking about KNO3 at 70 degrees. So we'll match up right here. Here's our 70 degrees. So what is our mass of solute? Take our line over here to the side. And as long as you're around the 130, that's a very good inference. All right, let's look at NaCl. NaCl, and again, I'm going to use the pink highlighter here. At 100 degrees Celsius. See right here? And you kind of go back. That would be 40 grams. NH4Cl, 90 degrees. And NH4Cl is here, 90 degrees. So that would be about 70. Okay. And then which of the above three substances is most soluble in water? So generally, the smallest amount of grams here in comparison, let's just say at 100 degrees right here, 40, 100 degrees. See how NaCl is lowest on this graph? That means it's the most soluble. The least soluble would actually be KNO3, because if you look at its line here, its line is going way up real quick. So NaCl is the most soluble because of its location here towards the bottom. All right, so let's take the same substances. We have KNO3, NaCl, NH4Cl, and what is the mass of solute that will dissolve at 200? Remember, our graph here originally is at 100 degrees. This is basically just doubling it. So if I had 200 milliliters, 2 times 130 would be 260. 40 times 2 would be 80. And 140, or I'm sorry, 70 times 2 would be 140. So it kind of gave you that answer. Part 2 is kind of like a fill in the blank. Remember those long definitions I gave you guys? It's not word for word what you would see here, but you're essentially taking those definitions and you're filling it in. So on a solubility curve, the lines indicate the concentration of a saturated solution. Okay, so what's the definition of a saturated solution? It contains the maximum amount of solute that will be dissolved at the specific temperature. No additional solute can be dissolved in these solutions at that specific temperature. Remember, temperature was key here. So anything else that is added into it will remain undissolved, generally at the bottom of the beaker. Values on the graph, you have to skip it, try and figure it out. A curve represents unsaturated solutions. Okay, I gave you this at the very beginning of this video. If it's unsaturated, on, above, or below. Unsaturated will be below the line. It will be below the curve. All right. Values on the graph. A curve represents supersaturated. Again, supersaturated, saturated, and unsaturated. Supersaturated will be above the curve. Where am I? Okay, here it is. Values on the graph above a curve represent supersaturated solutions. It contains more. I see some of this was whited out. It contains more than the maximum amount of solute that can be dissolved at that temperature. This is because when you heat up a substance, you add a lot more solute and you slowly let it cool down, the solution will hold more than it could at that particular temperature. Remember our snow globes? That's exactly what it's describing. It's describing our snow globes. So generally, this assignment or these notes will be going with an assignment that is front and back. Kind of looks like this. Front and back. And so what you're going to be doing is you will be completing that worksheet. If you have any questions, please email me. And of course, I will have the Google Meet open so you can ask questions. Or so if you need maybe a little help working through the problems, we can definitely work on some of the problems more one-on-one. But until then, I do hope that you have a good day.